Okay, good morning everyone. My name is Sai Anirudh Karre and I am a data product manager. Do their assignment on their behalf. You are actually creating a lot of harm to them. They will not get an opportunity to learn. Okay? So you have to let them learn. You can help, but you have to do that things like writing assignment, submitting notes, etc. Okay? Plagiarism and absentee policy, Dr. Vinay will take care of it. Okay, you are free to use any tool as you want because typically the way I look at it, in olden days there were textbooks. Okay, people used to rely on textbooks. Eventually, you have internet. People stopped reading textbooks. People started reading from internet. Now you have a GPT. People stop reading from internet and they're reading GPT. So tomorrow you'll have something else. So my point is, you can use them, but they should always be your productivity tools rather than replacing you. Okay. So the other item is with submission deadlines. The deadlines are fixed. There will be no extension. I will work with Dr. Vinay and Ashish to plan the activity so that it doesn't clash with other things. Like if you have any annual event or if you have any fest or if you have anything else, I'll ensure that I cater that and give an extra so that you can get and submit based on your respective timeline. Okay. Coming to grade policy and grade distribution, we have three assignments. The assignment breakdown is available in this page. You will have three homeworks and two mid exams and one final. I think this will be typically mid and final are typically written. Assignments are take home and homework is also take home. You can work by yourself like a group or a individual that way. Okay. And this is a fixed evaluation rubric. We follow this rubric for grading. So it will be a typical binary grading which will have address the requirement of the assignment, you will get the marks, otherwise you will get the okay. So if you look at the lecture topics which we're going to cover as part of this course, there will be 15 classes. Each class will be a typical 1 hour class, and in 1 hour class, we will try to cover as much as possible. Mostly Monday and Tuesdays, 8:30 to 9:30. There will be four parts to the class. First 15 minutes we'll talk about the concept. Then in next 15 minutes we'll draw some conclusion. Then next 15 minutes quiz, and then last 10 minutes we'll do the Q&A. Okay, that's all the typical workflow of the class. Every time when I set up a class, I will provide you the notes and the respective slides. And if there are any scripts or if you want anything to practice, if I want you to practice, I'll share them way ahead. Okay. So for today's class, they're up. For next coming week classes, I'll publish them maybe tomorrow or day after. So you will iteratively get the notes as we progress for this course. Okay. For notes, there is a grid book which I've created. I've only published content here or reading material only for first two classes. As we grow further as part of this code, we will start seeing more and more notes over here, and I'll tag it here so that you can read and understand. Okay, that's with the lecture, and reading material is a grid book. And these are the exams you'll typically have. Some bash and git in assignment 1, Docker and Kubernetes in assignment 3, which I think we will do it like a team activity. Then you will have a homework 1, 2, 3, which are typically take home question paper, and then mid 1, 2, 3, 4 are typical written. Okay. And if you have any questions, you can feel free to write to me at the email. It will be posted with latest updates. Any questions before we begin um, further? So, because this is an online lecture, I don't want to be as if speaking to a wall. If you have questions or if you are listening, feel free to add a comment in this chat so that if there are any others who want to look at and respond, they'll actually respond or I can answer. In upcoming classes, I'll post a query board. Okay, there will be a query board where you can just write your question anonymously so that you know I can answer and get you required queries answered. Okay? Great. Assuming that there are nothing in the chat, I assume there are no questions. So you have everything you need for this course. Let's begin with the course. Okay? So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. Great. Okay. So I think I collected some demography information to understand how many people are from industry and how many from uh, direct graduates who came from regular courses. I see that 80% of the class are not from industry, only 20% are from. So people who are in industry, you might have experience uh, while you were working in organization before joining the intake program. But it will help you connect certain dots and why these things, why we need DevOps, etc. Okay. So thanks for submitting that response. It gave a good picture on how deep I need to go. Okay, so let's look at, I think I use this one. Okay, I hope you guys can see the slides, right? Yes.
Yes, sir.
Okay, great. Okay, so what is DevOps? Imagine you were attending a function or a marriage. Okay, you see the bride and groom, families of bride and groom sitting on stage, receiving all the guests, and you go to the food counter and have food and leave the marriage, right? That's what you do. But in the back end, to make the show run, I mean, to run the marriage as an event, you have different people who work to support that event. Like if it's food, you need people who can cook, who can serve, who can arrange the food. If you look at bride and groom, to do makeup, you need a supporting staff, you need a person, you need a person who designs the dress. If you look at the stage, you need a decorating, you need a florist to assemble the flowers and to bring people to the transportation support, you need to organize everything and the support of ground staff who can clean and maintain the system. So for a simple marriage, your exposure towards the marriage is attending the event, congratulating the bride and groom, and then eventually go have food and leave. But in the back end, you have so many supporting staff who will help run the towards success, right? So basically, whatever the supporting aspect which happen to the event like marriage are like back-end operators. Those people facilitate by giving services so that a particular event can be performed. Right? So this is a real world example so that I can portray so that everybody can. Now, if you can correlate this with software production, okay, creating a product. In software industry, if someone is actually doing a product, like if you correlate with the event like marriage, they are actually depending on various facilitating stuff, like how you have a cook, decorator, florist, driver, transportation guy, cleaner. To facilitate an event like marriage, you have a facilitating team who manages a variety of aspects so that a product can be delivered to um, imagine what's the app you all use in daily basis. What's the top app you use? You can respond in chat. Which is the top app you use in your day-to-day life? You can unmute and respond. I'll repeat the question. What is the top application you use on your day-to-day activity? WhatsApp. Do you use Instagram? Yes, no. YouTube. What else? That's it. Okay. Assuming that people use Instagram, YouTube, WhatsApp, Reddit, Spotify, that's good. For music, different apps. If you try to correlate, people have been sharing good examples of apps like Discord, very nice. So each example which all the users have given over here have certain purpose, right? If you look at WhatsApp, you will go there and review the messages. You don't care whether the WhatsApp, someone in the WhatsApp is sitting and facilitating you that feature or not, right? Because you are the consumer and you don't bother about whether the feature is being maintained for you or is it shut down. All you bother about whether I can use that feature or not as an end user. Like for example, YouTube. You will be bothered if you can see your favorite star's trailer which is out 10 minutes ago and you don't bother whoever is working in the backend to facilitate that video. Similarly, with Reddit discussion threads or Spotify music recommendations or a Discord file sharing or any forum related activity. As a consumer, you are trying to interact with those platforms so that you get the features which you are interested for, like messaging for WhatsApp, watching videos on YouTube, listening to music in Spotify, and engaging with Discord. But when someone is trying to introduce new feature into these platforms, there are bunch of people at different levels participate and facilitate to run the apps run with the latest update. Okay, so those teams, whoever facilitate these activities, are typically nothing but a back-end operator. So they are like people who facilitate the developers to create and deliver it to the apps which is eventually used. So in short, DevOps is nothing but back-end operations for your development team. Okay. So if someone is writing a feature in WhatsApp and releasing it to you, it means that it runs through someone with the assistance from a DevOps. If you are using a Reddit thread to interact or engage a discussion, if someone is facilitating a feature in Reddit, it means that it has an assistance or a facilitation of that service through a DevOps team. Similarly, if you are trying to interact with a forum-based discussion through Discord, you are actually being facilitated by an underlying team at Discord called DevOps. So DevOps is a back-end operations team It's typically a developer operations team which will help the development team perform their job. Okay. So if you look at this image, I think credits to the respective owners of this image. But if you look at the image, there are different layers. You can see an application development and definition layer, orchestration layer, runtime, provisioning, infrastructure. In the right side, you have platforms and observability. These are the typical responsibilities or the overall tool set which people typically work as part of developer operations. In this course, we will try to go into each of these uh, uh, categories so that you understand how these operations will help the engineering team, the product teams in a company to build a product and deliver it without any hassle. Okay. So in short, DevOps is a developer operations team. It's like a backend support team for a marriage, like how you have the example I have given before. Similarly, for releasing a product, you have a backend operations team to facilitate all these activities for people to build better products. Okay. So you have a backend operations team, and how do they execute and help the development? So there are some example delivery pipelines. Okay, the first image if you see talks about a typical website delivery pipeline. For example, if you are creating a website, like a website for a news feed, like Times of India or the Hindu, or creating a website for a news like Manorama or Asianet. There are certain levels of development that website engine will do. At every level, there are various aspects involved to see are we doing the right job, what are the requirements, are we building the requirements, are we delivering those requirements, is the requirement facilitated in the final UI. Typical website development workflow will look in this way. So to ensure that someone is gathering requirements and delivering a product for them, you need an underlying tool set to facilitate. So in so that's where all these tools will eventually play role so that these people can develop typical websites. Another example for data pipelines. Typical data pipelines are pipelines where we know data will be generated by certain source and it will be captured by a developer, database engineer, and they are streamed into subsystems by another engineer, and then it is facilitated to consumer in the form of reports or dashboards. So even for this data pipeline, there are to be certain backend engineers who have to facilitate to keep the database up and running, the visualization both up and running, the data pipeline to be up and running. Someone has to monitor whether the entire data flow is working fine or not. So for that, you also need DevOps in practice. Okay? The third image, what you see is design workflow. So if someone is actually trying to design a logo or trying to design a feature, like for example, WhatsApp recently released a feature which is associated with payment. Okay, they got an exclusive license to do payments through WhatsApp. So to enable payment through WhatsApp, you need an authentication layer. You need a way to accept UPI as a protocol and do bookkeeping of all the transactions and the contacts. So when someone is trying to design this workflow of when to send money, to whom we need to send, how we have to show the acknowledgement, even for that you need underlying tools where facilitation is required. So at all aspects of product development, the DevOps team will help in assisting the developers, be it website development, be it data pipeline engineering, be it engineering, be it design engineering, at all pieces of the software production, the DevOps engineer will come into picture, facilitate you to create to do your job, which is nothing but Now, how will it help? How will the DevOps team help? What impact will they create in general impact? So, without any supporting staff, it is very difficult to organize a marriage, like to bring back our first. It's very difficult to conduct a marriage if you don't have a decorator, if you don't have a cook, you can't open a food stall in the food counter in the marriage. So the way you supporting staff for a marriage, so that you can make the marriage productive and make it success. Similarly, engineering team, if you don't if you don't make use of or best use of the DevOps team, you cannot achieve the productivity of your development team. Imagine if they have to deliver 10 features, and if you don't have a DevOps team to support them, they might only end up releasing one or two features. Okay? So the impact of DevOps team will have is actually directly proportional to the productivity of the engineering team, and also it will avoid what we call software development waste. Software development waste is you create a feature, but you don't use it. You develop a feature, it doesn't go to production. You redo the same activity, not knowingly. Your colleague in the same company might be doing same thing, but you don't know that you're working on same item. Which is, so if you don't have a DevOps team, you will lose your productivity. You will create a lot of waste. There will be a challenge between different things because they don't talk to each other, and eventually they will uh, uh, don't contribute towards the release of the product. So there is a huge productivity impact the DevOps team can give. So any one of you who eventually want to become a DevOps engineer, you will not only be a facilitator to the organization, you will also become the facilitator for productivity of the organization and also avoidance of waste. So that is where a lot of metrics come to in picture. As part of this course, we'll see what are those key metrics, how do you compute those metrics, how do you calculate waste, how do you calculate metrics associated with DevOps, how do you do impact analysis, root cause analysis. We will see all those things in the upcoming course so that you'll understand the real impact when for an engineering team to release the product. Okay. So at large, this is what typical DevOps is. DevOps is basically a backend operations for an engineering team. So there are variety of tools involved. You will get an exposure of what they do, what are those tools, and how you can best use them so that you can create things in practice. If you look at the typical course outcomes at large, we will try to brush up our understanding on operating systems, some level of batch scripting. Then we will do version control using this. We'll understand how software engineering teams operate, what are the metrics they compute. We'll do some metric calculations in one of the assignments or homework. I'll give you a use case where you have to compute metrics and come back with the results. Okay. Then we'll talk about CAMS model, which is a well accepted model for people to manage their overall engineering operation. And then we will look at CI/CD, continuous integration, continuous delivery, how software products are delivered at large in a continuous format. What is SaaS? What is platform as service? We'll all look at it CI/CD part of the course. Then we'll look at platform as service and orchestration. These are typical deployment styles or delivery of product styles. That's where we'll look at things like Docker, Kubernetes, and how people use. What are the alternatives of Docker? What are the alternatives of Kubernetes? Why they are useful? Why they are not used by all? Why only certain companies don't use it? In a secured setup, how one has to write their own orchestration tool. So all these things we'll look at in the orchestration. Then in the end part of the course, we'll look at What's the day like a DevOps engineer looks like? What tools they use? What activities they perform? So I'll bring in some 10 to 12 examples from real world industry. How a DevOps engineer in Microsoft Office team look like? How a DevOps engineer for Oracle Hyperbase database looks like, and how a DevOps engineer in typical a SaaS platform like UPI or any payment Stripe look like. So I'll give you their roles, responsibilities, tasks they perform in those real world use. In the end of the course, we'll look at the future of DevOps. Uh, there's a new variant like ML ops, machine learning ops, where machine learning can be applied. What are the directions for automating certain pieces of these DevOps operations? And also we look at some aspects of DevSecOps, which is nothing but a security operations for development team. This is predominantly where we try to understand some data laws, GDPR, how DevOps will facilitate securing the engineering environment, all those aspects. Okay. These are typical course outcomes which will eventually come out and you'll understand through this course. And if you have any questions, please feel free to let me know now, because after this we will eventually move to some concepts with operating system. Any questions so far? Are you okay with the pace, speed, or do you want me to be more slow? Or is everybody sleeping?
Sir, this speed is fine.
Okay, okay, okay. Great. Okay, the first lecture will typically for any course will be boring because it's basic introduction to set a preface on what that underlying subject is gonna be. So it's okay that you will be bored, but eventually as we go further, I'll try to keep it hands-on. We'll do a live activity so that we'll understand concept way better. Okay. Okay. Now let's look at some basics. You'll have to. I think. I hope everybody are from CSE background, or is anybody from non-CS background? Please do let me know now, so that I'll try to portray the idea of operating system bash in that. Everybody is from CS. Okay. Okay. Vishu and Sajil, which branch you are from? You can
Mechanical,
answer.
sir.
Mechanical. Okay, that's fine. Vishu, how about you? Civil. Okay. Anybody else? Engineering, physics, controls. Okay. Anyone else? Only three. Okay, great. So, whatever concept I'm going to teach, I'll try to be very generalized in nature so that people will try to understand and for you. Okay. Let's look at this slide. So, at large, I'll just talk about hardware, software, and something called bootstrapping. Okay. So that people can understand the basics. So this uh, uh, these slides will set a benchmark so that you'll understand. I assume that you understand anything below it. After this, something which will eventually part of this. Okay. So there is something called hardware and software. Both of these aspects constitute computing device. So if you look at the typical hardware, the hardware consists of an input-output devices for your machine which you are using. Your input device is keyboard and mouse pointer. The output device is your monitor and audio speaker. Okay. The hardware device, if you break it, you will see a memory unit, which is primary and secondary memory. Primary is your SSD drive or hard disk if you're using CPU, or if you're using any mobile phone right now to listen to this, you have a what we call ROM inside it, which is nothing but read-only memory, where it stores your data permanently. The temporary memory is called RAM, which is random access memory. It is typically memory space where whatever you do live will sit there. Okay. And then you have the heart of your machine, which is your processing unit. Okay. That processing unit is actually connected with all these devices, input, output, your memory unit. Okay. And the connections are typically called as buses or the wires. The wires inside them are typically called. How many of you have actually broken your CPU, typically your undergraduate, and have seen what does it contain inside? Have you tried opening your CPU in the past? Yes, no, or you only had an exposure to your laptops for the first time. You have never seen a CPU before. Okay, some said yes. So if you look at a CPU, maybe if you can find a CPU in campus, I think you seek a permission from your someone from lab and open the CPU. Okay, open the CPU. You will find the hard disk. Yeah, yeah. So this is how a typical CPU looks like. You will find a hard disk. It's called SMPS, which is the power unit. Below that, you will find a hard disk. This is your motherboard. Okay, and these two slots are typically RAM slots where you have a random access. And yeah, you will see something like this, which is nothing but a heat sinker, which reads the things like heat. And you'll see bunch of other features. So you will be a fan to a processor, um, and you have a microprocessor like this, which is actually connected to small transistors and registers, which will connect it. All these aspects are actually binded to these lines. Okay, if you look at these lines, which are fabricated on this board, are nothing but buses. Those are the connectors. Okay, they connect all these hardware devices with particular. And apart from that, there are wires you see which are connecting one hardware to another. These are typical wires. Okay. So a CPU like this will have certain computation power. Okay. Look, if you look at your mobile phone, when you go buy your mobile phone, you see that your mobile phone is typically has some 128 GB of RAM and uh, 8 GB of RAM and 128 GB of ROM. You see those specifications, right? Those are nothing but the temporary and permanent memory, which will typically help you run the show on your mobile device. Similarly, for your laptop, you have a certain configuration plan. And if you scale the power of your machine, you can even to store large CPU. That's why there are something called data centers where you see huge machines which are connected with all their CPUs, random access memory are actually connected to each other. Okay. Here they are not called as typical CPUs, they are actually called as racks. Okay. Every rack you see over here has a CPU hard disk, it has a RAM, ROM connected to a bus, and this becomes a very big computer. Okay. So for a DevOps engineer, it is important to know that you don't play with a computer. You actually play with a huge computing device which typically has a lot of RAM, a lot of ROM, and all the activities you perform will be played on top of this huge environment. Okay. So if you compare the size of your machine or your device which you are listening to the course right now, it is limited or bounded by certain type of space and hard drive. Okay. But over time, when you enter and become a DevOps engineer, you will see a huge exponential growth of the computing power where the chips are connected in series or parallel, multi-core, territory core, 12 core, 13 core, 24 core together with the support connectivity with the memory unit will actually spike the overall capacity of the machine. So the ingredients of a higher computation power is the way you organize your hardware. When you join any organization, your organization has any data center, you get an opportunity to see how it is organized. And this organization of the hardware will be handed to a DevOps engineer to consume and scale. Okay. So there's a guy called Gordon Moore. Gordon Moore predicted that every 2 years, uh, um, the way we look at a memory of a hardware device, the computation power will actually double. Okay, that's how we envision. But now it's not doubling; it's exponentially raising. Okay? So when an engineering team is trying to build a product, they need some space in some hardware to run the program or whatever product they're using. To facilitate that space or create copies for testing or any other purpose, you need more and more hardware. So typically they don't rely on a single source of hardware, they rely on what we call data center. Okay. So that is where it's very important to understand what level of hardware is required for what combination of a system you build. Based on that, you can configure your hardware accordingly. Okay. Similarly, if you look at the aspect of software is nothing but set of keywords, rules, uh, in the form of syntactic and semantic, which will frame a language, and where you write code in certain language, the machine will interact and you will see the response. Okay. There are typically three levels of languages which engineers should know. One is the higher level language, which everybody uses today. What is the language you all know in general? Do you all know Python? Or do you all know at least C? You can type the language, whatever languages you know in general. So I think I have received some from the feedback form. Yeah, I think most of them know some level of web, some level of Python, some level of .NET, Java. All those languages are called as high level languages, which are the languages where you write your application. But to bind and run those languages, you need an interface between a software and hardware. That is called an assembly line. Okay, which typically talks to your hardware of your machine. Okay. Then inside another at a circuitry level, there is called low level language. Verilog, VHDL, those are all low level language. They design, they ingest code in the hardware so that the circuit works on circuit. Okay. So if you look at the diagram here, your hardware is physical. Your hardware talks to a low level and assembly level language called a software called operating system, which is typically written in low level, high level, and a lot of assembly level. On top of operating system, you write your application and you expose them to the end user. Okay. So all these typical software languages play with two rules. One is syntactic rule and semantic rule. Syntactic rules are nothing but the syntax, the code construct. For example, if someone is asking you to write if and else in C, you write if bracket open bracket close, lower bracket and then write else, right? So these are syntax. What are semantics? Semantics are what type of a syntax is come after certain part of the syntax. How do you organize your code? What is the command line of execution? Which is your first function which needs to be executed? All those are semantic. So this syntactic and semantic rule combine to create a typical language. Okay, and all these languages are categorized into two parts. There are compiled languages and there are interpreted languages. Compiled languages are languages which give you output after doing the rule check of the syntax and semantic rules in one shot. Okay, And the interpreted languages are languages where the semantic and syntactic rules just happen line by line. They'll verify whether the rule is abiding in line 1 and give you the output. They do the line 2, line 2, line 2 in this. So now give me an example of compiled languages. You can feel free to type. If you don't type, I'll assume that you have no clue. Okay, C++, what else? C++. That's it. Only compiled language. Okay, there are many other languages which are compiled, like Smalltalk, Scala, the typical compiler-based languages. What are the interpreted languages which you know? Uh, which is, okay, HTML is a very HTML is a very simple interpreter language which will execute things line by line. Okay, so I'll write something, some notes in the guidebook, so that you understand that. I forgot to mention that, but I'll add what are interpreters, what are compilers, because it will help us when we discuss about various types of models of organizing the code, doing it, all this stuff. Okay, so these are typical hardware software. Okay, but when you uh, when you infuse these hardware
तो
and software,
खत्म हो गया
sorry,
तो काफी टाइम तक चल चुका हूँ उठा मार रहे तो हमको तो लगा तुम कितने गए
Guys, mute yourself.
okay. So when you infuse this hardware and software, um, you eventually rely on what we call an operating system. Okay, so you have a high configured hardware, but if you want to make use of it, you need a software called an operating system. Operating system behaves like an interface between a user and hardware. It facilitates you so that you can make best use of your hardware. But the operating system will not work by default. Okay? So when the machine is off, the operating system will typically shut down. But when the machine is on, there is a program called Bootstrap program which will kick your operating system uh, when the machine gets low. To experience this in real time, what you can do is after this class you switch off your mobile. Okay, when you switch on your mobile will show a logo. For example, if you are using Motorola or iPhone, they show you a logo and they'll make you wait. Okay, there will be a progress bar or there will be a progression cycle which will roll, and after 30 or 40 seconds, your phone will wake up. Right? It's actually running a Bootstrap program in the backend. Okay? Bootstrap program is a program which will invoke all the hardware components. It will turn on the input device, it will turn on the output devices, it will ignite the microprocessor, it will ignite all the registers, it will enable the memory, enable the ROM. So that program is the kicker program which already sits in your ROM or in the disk, which will enable or wakes up all the hardware and brings it to your main memory and tells you that this is the machine which is on. In olden days, maybe in old versions of Windows, you might have seen a blue screen or a brown screen where a machine is getting turned on, or a black screen. If you're using a Ubuntu, you still see that when you turn on Ubuntu, bunch of programs run in the background and then it will bring back your text. That's called a bootstrap program. The bootstrap program typically helps you enable your operating system and bring all the applications to function. Why this is important? For a DevOps engineer, when you're dealing with large hardware and if they're connected in series, if one rack, one CPU is connected in the chain, if it is not working, then either it could have an issue with the underlying hardware support or there could be a challenge running at the bootstrap. So the idea is you should have some basic understanding on what a bootstrap program is, what is the level of the bootstrap program, how it operates. I'll add more notes in Gitbook so that it helps you reading. Okay. Typical bootstrap program, I assume it should already be covered in your undergraduate in your operating systems course. But this is just a overview so that you brush up the idea of what is bootstrap. Okay. So assume that now your machine is up. Bootstrap kicked off, your machine is awake, and now if you're using your phone, you will be landed in home screen, but if you're using your laptop, you will be on desktop. Okay. There are two modes in which your machine is now operating. The first mode is called kernel mode. The second mode is called user mode. Kernel mode is a place where your operating system, your hardware related management software like process management, if you can uh, 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 revise and memorize brush up your memory and think about concepts of preemptive algorithms, non-preemptive algorithms from your operating system course in your undergrad, which will typically manage your processes in your operating system. I think the textbook name is Operating System is Peter Gallion. So I think that's a standard book everybody uses. In that you will have concepts like preemptive, non-preemptive process management. Similarly, for managing memory, RAM and ROM hardware, you have memory allocation, contagious memory allocation, non-contagious memory allocation. These are the algorithms which actually run in the kernel. Okay, they will help you to bring an application into the user mode. When you use it, store the temporary data, storing permanent data, all those underlying programs will run at a kernel. Okay. At a user mode, if you are opening a notepad, if you're opening a WhatsApp, or if you're opening a Twitter or LinkedIn or any calculator program on your screen, like in a mobile phone or any application in your laptop, they are actually being operated in user. So if you open WhatsApp, the WhatsApp will use standard library, like for opening, closing. For example, in your mobile phone, if you want to open an app, you just click on the logo of the app, right? So when you click on a logo of the app opens. So it actually using underlying standard system library called open, okay, which will enable on click on that app to launch the application. If the app is not getting closed, what do? You click on the cover icon in the last piece of your menu and swipe it. Right? You swipe the app in the side and you will fill that app. That is nothing but a close function. So the kernel mode, while it facilitates managing your hardware, the user mode provides certain standard library to manage your applications at user level, at a user interface. All those libraries and utility programs come like a package in your operating system. So if you're using Windows or if you're using Ubuntu, in the backend there are random standard libraries which are running continuously. How do you look at if you're in Windows? You can just go to what we call Task Manager and you will get to see bunch of programs which are running in the backend. Okay, so you can observe machine is alive, there are a bunch of programs running, and this is the memory they are consuming. So among the ROM and RAM, 100% in my machine, 43% is being consumed by all these apps. This is the disk space which is being consumed by all these apps. And if you look at monitor, it will show you what the usage of a CPU, what the usage of memory. All these stats are actually coming from the utility program or the standard library program which take care of the activities that a user. Now I am using PowerPoint in my machine. So you will see a utility program associated with PowerPoint somewhere over here. Okay, so if I sort by, yeah, I think somewhere. So I'm also using the browser, open browser. I see all the associated tabs which I'm using with the browser. So the idea is When you are interacting with your machine, you are actually invoking the bootstrap program. You are actually playing the bootstrap program at a kernel level and trying to open standard libraries, and at a user level, you are interacting with your uh, 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 application as a user. Okay. So today, when you are actually trying to use any app in the UI, you have a graphical user interface to perform this task, right? For example, on my screen, if I have to minimize the browser, I will use this minimize button and then minimize. If I have to close a window, I'll click this crossbar and I'll close the window. Or if I have to open Excel sheet, if I double click on it, I'll open Excel. So my mouse events like double click, single click, drag and drop, zoom in, all these are actually facilitating me to perform my standard utility programs on my kernel. But behind all these actions, there is a intermediate program in the utility program which will help me perform the task. That program is called shell. Okay. So shell is like a gateway between and the kernel. So if you look at the image in the right side, all user requests like closing the window, minimizing the window, maximizing the window, opening the file, closing the file, restarting the machine, shutting down the machine, moving one file to another file, copying the file, deleting the file. Whatever task you perform in the GUI of your operating system or any computing device, your mobile phone or your smartwatch or any other device, there is a program called shell which is facilitating you to perform this. So basically, shell is like a command line interpreter. Okay. It's an interpreter it will read the command and help you interact with the kernel. So if you want to copy a file from folder A to folder B, you should tell the shell. Shell will help you do that. If you want to delete a file, you should tell the shell to delete, it will delete the file. Now, how to inform the shell, how to talk to shell, all those things we'll learn in what we call bash scripting. Okay. So in the next class, we will start with bash scripting. I want you all to install bash. If you're in Ubuntu, you already have bash by default. If you are in Windows, you can go to Windows Store. So you can go to what we call Windows Store, Microsoft Store, and there will be a app called Ubuntu Subsystem. Ubuntu Subsystem. You can install any one of these. I prefer 22.4 or 24.4. All are free. When you install, you will get an app like this, Ubuntu on your own machine. Okay, and then we can eventually use that for our next session. Okay, so the notes for the next class is up in the Gitbook, where I have written some basic commands, some concepts regarding what is kernel, what is system space, how to install bash. I think partly of this you already aware from your undergrad course of operating systems or Unix, but this will be like a refresher so that when you start working on actual activities of DevOps, you will understand what exactly a DevOps engineer typically do. Okay. Our focus will primarily on the conditions and loops and managing files. Okay. So I've added all the required notes here, and there are some good examples which will help you understand the scripts in detail. Okay. So in next class, I will run through batch so that we will understand how to talk to the underlying kernel and operating system and get whatever we want. Any questions so far? If there are no questions, just type no so that I'll understand that. Okay. So in the end, this is an intro class where we just try to understand what DevOps is. Eventually, we'll go through this schedule. Okay? In next class, we will do batch scripting. So I want you guys to install batch. All instructions are there in the Gitbook. There are also sample scripts and past practice scripts. So please go to them. I'll run through those scripts manually in the next session so that for people who have no exposure, will can pick it up. And your first assignment will typically be on that. Okay, great. If there are no questions, then we'll call it a day. Thanks for your time. Ashish, we are good.
Yes, sir. Thank you so much.
Okay, thanks everybody. Have a great day. Bye.
Bye, sir.